Okay, so here's my little continued fraction. Just I made a for loop. I'm going to look at the first 10 fractions. So I do from continued fraction of continued fraction with I terms, where I starts from 1 and goes up to 9. Okay. So the first good approximation from continued fractions to pi is 3. Then 22/7. Have you ever heard of that approximation before?
Yeah.
Yes.
So it turns out to be a pretty good approximation. Let's go down here and do n of pi to 10 decimal places and n of 22/7 to 10 decimal places.
You already got it too.
So it's basically 3.142.
You already got it to 2 decimal places.
Yeah. Now it turns out the next good approximation is 333 over 106. And so what product of pi is nearly equal to an integer,
So
according to this?
106 times pi is almost 333.
Yeah, so let's look at n of 106 times pi. And we expect this to be pretty close to 333. In fact, it's 333.008. 0088, actually. And then we get another really good one, that 113 times pi is very, very nearly equal to 355. So there's another 106 times pi and 113 times pi are almost integers. 354.9999699.
Well, it was interesting. It was a little less this time.
That's, hey, high five. Good thing to notice. You can be close to integers in 2 different ways.
Yeah.
Sometimes you can be above, sometimes you can be below. Is 3 above or below pi?
Below.
Below. Do you remember, was 22/7 too big or too
It
small?
was a little big. I think it was 3.1428.
Yeah, so it's going to turn out with continued fractions, it's going to go a little less, a little more, a little less, a little more, a little less, a little more, so it sort of bounces in.
And then it's going to eventually just converge on it.
Well, yeah, you can see that it's converging real quick, but of course it'll never be exactly equal. But here's one of the neat things about pi. The next good approximation to pi after 355 over 113 does not occur until 103,993 over 33,102.
Wow.
So at 355 over 113, .141592, 355 over 113 is an astonishingly good approximation to pi.
Yeah.
In fact, there's no denominators up to 30,000 or 33,000 that are better than 113. That's pretty remarkable.
Wow.
This also seems to be a big jump between these two.
Yeah, you're right. You're right. It's not as big. This is going from 355 to, well, sorry, the bottom's going from 113 to 33,000. This bottom's going from like 100,000. Was it this one? This one to this one?
Yeah.
So this one's multiplying just by about by 2, but it's still a pretty big jump.
Yeah.
So that's pretty cool, right?
Yeah.
Yeah, so 355 or 113 is probably as good an approximation as you'd ever need for anything, but 22/7 is good enough that that's what most people use when they need approximations. But we can look at this for other numbers too, so why don't you just pick a rational, or pick an irrational number for me?
How about square root of 11?
Square root of 11, okay. There we go. 3 10/3, 62 over 19, 199 over 60, 1257 over 379.
So maybe 60 is a pretty good approximation, the 199 over 60, because we got another big jump.
Yeah, so let's see. 60 times the square root of 11. So this should be very nearly equal to what?
199.
We get 198.997.
Be close.
Yeah. And by the way, this means also that 199 squared divided by should be very nearly equal to 11 times 60 squared. So let's look at 199 squared, and let's look at 11 times 60 squared. 199 squared is 39,601, and 11 times 60 squared is 39,600.
Wow.
Not even one apart.
Yeah, pretty cool, huh? All right, pick one more. Pick one more. You pick an irrational number.
Let's look at E.
Let's look at E. Yeah. So E, I'm going to have to go e to the 1. So I get 2, 3, 8/3.
That's the first one
11
with 2
4.
integers.
Oh yeah, good thing to notice. 19/7, 87/32, 106/39. So we don't see the same jump after that we saw in pi. Or pi, the numbers, because we had one approximation that was super close, the numbers got large really quick, but that doesn't happen with E. Maybe we can do 20 approximations and see if we get a jump anywhere.
Well,
Oh, there's 2,000 to 23,000.
Oh yeah, there you go. That's good. So it's, looks like it's going up by a factor of 8.
50 to 500,000.
Yeah, there you go. There's a factor of 10. So we do get some pretty good approximations. They're just a little bit larger. So 49,171 over 18,089 is a really good approximation.
1 million to 13 million.
Ooh, nice. Yeah. So it's a neat technique for finding approximations to numbers, and it works extraordinarily well.
yeah.
And the neat thing is it's really simple, because all you do to find these continued fractions is, what's the procedure?
You split, flip, and rat.
Split, flip, and rat. All right. Good work, guys.